Hi everyone, so today we're going to go ahead and review trig functions. So you will need to know your unit circle. So when we're evaluating each of these, you're going to go to your unit circle and identify what the terminal point is, as well as evaluate at each of these trig functions. So at 7 pi over 6, we know that our terminal point is negative root 3 over 2, comma, negative 1/2, and when we are trying to find secant, secant is the reciprocal of cosine, which is our x values. So I'm going to take my x values and write the reciprocal of it, or you can also rationalize and give both answers. In 4 pi over 3, we have negative 1/2 and negative root 3 over 2. Now tangent is the y value over the x value. So you are going to do negative root 3 over 2 divided by negative 1/2. So you know that the 2's will cancel, the negative will cancel, and you're going to be left with the square root of 3. In pi over 6, that is root 3 over 2 and 1/2. Cosecant is the reciprocal of sine, which is our y value. So I'm going to take 1 over 2 and take the reciprocal of that, which is 2 over 1, which is the same thing as 2. In 5 pi over 6, that is negative root 3 over 2 and 1/2. So cotangent is x over y. So that is negative root 3 over 2 divided by 1/2. Again, the 2's will cancel, and I'm going to be left with negative root 3. In pi over 2, our terminal point is 1, 0. So with tangent, it is the same thing as y over x. And again, remember that 1 over 0 is not 0. That is actually undefined. In pi over 2 again, same terminal point as 0, 1. Cotangent is x over y. So x over y is 0 over 1. That is what reduces to 0. In negative 2 pi over 3, again, that would be in the same location as 4 pi over 3. So that terminal point is negative 1/2 and negative root 3 over 2. Our sine value is our y, and that'll be negative root 3 over 2. And with negative 11 pi over 6, that will land at the same spot as pi over 6, whose terminal point is root 3 over 2 and 1/2. Cosine is our x value, and that gets us root 3 over 2. Okay, in question number 2, it's important for us to see that if we have our angle in standard position and our point is at 2, 4, that means that when we look at our triangle, that distance is 2 along the x and 4 along the y. And we are looking, of course, at secant. So secant, remember, is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant has to be hypotenuse over adjacent. So we do have our adjacent side. If this is theta, you do have the opposite side. We are trying to find our hypotenuse, so you're going to have to use the Pythagorean theorem. So it's 2 squared plus 4 squared equals our x squared, which is our hypotenuse. So you have 4 plus 16. And that gets you 20. And if you take the square root, x is going to equal the square root of 20, which is the same thing as 2 root 5. So when we are trying to find secant of theta, you have your hypotenuse, which is 2 root 5, over your adjacent side, which is 2. Now to simplify that, you're going to notice that our 2's will reduce, and that'll just get you the square root of 5. In question number 3, you actually need to figure out where to draw your triangles. So Remembering our little acronym, all students take calculus to help us to figure out where our triangle is going to be. Cosecant is going to be a negative 6 over 5. Now again, remember that cosecant is the reciprocal of sine. Sine is only negative in quadrants 3 and 4, so we're not going to be in one of these quadrants because that's where sine is positive. And tangent is going to be less than 0, so tangent has to be negative, so we're not going to be in quadrant 3. So we're going to draw our triangle in quadrant number 4. Now, what we're going to do is we're going to say, okay, well, I know that cosecant of theta is negative 6 over 5. Okay, so reciprocal over 5, that means I have hypotenuse over opposite. So my hypotenuse is going to be 6, and the opposite is going to be 5. Now, remember that the hypotenuse can never be negative, so the negative sign that you see in front of the 6 is actually going to be right in front of the 5. Now, in order for you to find cosine, which we know that cosine of theta, and we know that that's going to be the adjacent over hypotenuse. Well, we know the hypotenuse, that's 6. But in order for us to find the adjacent side, we again need to use our Pythagorean theorem. So you have x squared plus negative 5 squared is equal to 6 squared. So that gets you 25 and 36. So x squared is equal to 11, which means x has to equal the square root of 11. So our adjacent side is the square root of 11. So our cosine of theta is going to be square root of 11 over 6. Okay, in question 4, you are looking at arc cosine, so you also have to remember where you have your range for arc cosine. That's from 0 to pi, so in 1 and 2. When you are trying to find negative 1/2, you're again asking yourself, I'm trying to find some angle whose cosine is negative 1/2. So in that range, I am looking only right here at that particular angle, and that angle is 2 pi over 3. Now for arc sine, we are looking in quadrants 1 and 4. So this is getting us negative pi over 2 to positive pi over 2 for my range. So again, you're asking yourself, okay, so the sine of some angle has to be negative 1/2. So again, I'm looking for sine, and I'm looking right over here. Now, although you would say, oh, this looks like 11 pi over 6, that actually does not fit in the range. So you got to look at the negative of that angle, and the negative angle is negative pi over 6. Okay, so here, again, you have an inverse sine. It's just not written as arc sine, but again, you need to think about where you are, so in quadrants 1 and 4. So again, ask yourself, the sine of something has to get me negative root 2 over 2. So I know I'm going to be right here in quadrant number 4. So again, remember the range is negative pi over 2 to positive pi over 2. So to find your angle, it has to be the negative of that angle that is located right there in quadrant number 4. And that angle is going to be the negative pi over 4. Okay, so in number 7, you can think back to the couple different questions we did involving composition of trig functions and their inverses. So the thing you can do is remember the rule, or you can figure out what's in the inside and then what's on the outside. So these two functions are not direct inverses of each other, and the ratio is not on the unit circle. So you will have to draw a right triangle. So I'm going to start from the inside. So with arc sine, I'm going to remember that I'm looking at either 1 or 4, which means that my triangle, because I'm looking at sine, for the y being negative, that triangle will have to be in quadrant number 4. Now thinking back to sine, sine is opposite, so negative 2 over hypotenuse. So the negative is going to go with the 2 and not the 5 because the hypotenuse can never be negative. So I want to figure out, okay, well here is theta. I want to figure out what's that missing side that I have here. if I do my Pythagorean theorem, I have x squared plus negative 2 squared equals 5 squared. So that gets me 4 and 25, which gets me 21. So x equals the square root of 21. So now that you have this triangle, what you're going to do is you're going to say, okay, I've got the triangle. Now I'm going to evaluate this second function on the outside with the triangle that I found out with its sides all filled in. So if I want to look at that triangle here, I'm looking at cotangent. I'm looking at cotangent being adjacent over opposite, which is going to get me the square root of 21 over 2. Okay, so in number 8, again, when you're doing a composition, you can again remember the rules, or you can look at the inside function and then to the outside function. So here, your inside function is the cosine of 5 pi over 4, which we know is negative root 2 over 2. So then what we're doing is we're taking our outside function and saying, okay, well, let me figure out the arc cosine of whatever I just found out. So with arc cosine, remember you are in quadrants 1 and 2. So if we're looking at a negative angle right here, with the cosine of negative root 2 over 2, that angle would be 3 pi over 4. Okay, so in number 9, we're going to look at, again, the inside first. We are looking at arc cosine. So again, that's not in quadrants 3 or 4. If we're looking at cosine being 12 over 15, that's a positive cosine. So we're going to look at quadrant 1 with our triangle. We are looking at adjacent over hypotenuse. We can then find the opposite side. Now, this is a variation of a 3, 4, 5 triangle, so that opposite side is going to be 9. So that triangle is what the inside was. So now we're going to look at the outside, so cosecant, and then we're going to take cosecant and we're going to evaluate it with the information we've got from our triangle. So now cosecant of our triangle is going to be the reciprocal of sine, so that's going to be the hypotenuse over the opposite side. So that's going to be 15 over 9, which is the same thing as 5 over 3. So in number 10, let's find our amplitude first. So that is the number that is in the front. So that is 3. We are going to find our period. So that's 2 pi over b. So that b value is 2, which means our period is pi. Here we do have a phase shift. We are going to the right pi over 3. And then we do have a vertical shift, and that is going down 4. So remember with sine graphs, we are starting at our midline and then either going up and down or starting at the midline going down and up. So because this is positive sine, we're going to do that first option. So we're going to go ahead and graph here. We'll give ourselves a little bit of space. So your midline here is we're going down 4. So this is where your midline is. Our amplitude is 3. So we're going either up or we are going, give ourselves a little more space, we're going down 3. Now to do the period, we have to go to the right pi over 3. So that's our phase shift. And the period, that means you have every 4 tick marks. So the one full period is going to be 4 tick marks. So you got 1, 2, 3, 4. So you're adding a pi. So the very end is going to be really 4 pi over 3. So what we're doing is we're saying, all right, we're going to start at our midline. The highest point is going to be the next tick mark. The midline again is going to be the next tick mark. The very bottom is going to be the following tick mark. And the last is going to be right back at the midline again. All right, in number 11, we are looking at same information. Our amplitude is 3. We are not taking the amplitude and saying it's -3. Now, the negative will be important when you're thinking about how you're going to start drawing your cosine. Next, we're going to find our period, so 2 pi over b. Now, our b value is not factored out, so if we factor out our b value, it'll help us to see our phase shift a little better. So our b value is again 2, so that equals pi. So 4 tick marks is 1 full period. You do have a phase shift. Now that phase shift is going to the right, pi over 2. You do have a vertical shift of your midline, which is going up 1. So remember with cosine graphs, we're not starting at the midline. We're either starting at the top, going back down, or we're starting from the bottom, and then we're going up. So this is a positive cosine graph. This is a negative cosine graph. So if you're a positive cosine graph, you are going to start positively or start up. If you're a negative cosine graph, you're going to start at the bottom. So because this is a negative cosine graph, we're going to start at the bottom, so our lowest point. So sketching a graph here, our midline is at 1. So our amplitude is 3. So we're going to go up to 4. We're also going to go down to -2. Now you have a phase shift going to the right, pi over 2. So again, 4 tick marks, 1, 2, 3, 4. Again, you can start just drawing your period and then adjusting your number. So it's really up to you. So going all the way would get me plus pi. So the end is going to be pi over 2 and then the period. So that would be 3 pi over 2. So when we graph, we're going to start at the bottom. Next point is our next tick mark, going to the top, going back to the midline, and coming back down. So we're going up, curve, and then down. So that's 1 period. And again, remember, you can continue your wave pattern as well. So the next questions are going to be focused on the law of sines and the law of cosines. So you do have to remember to put your mode in degrees because you're going to be given your angles in degrees for these questions. So we're going to draw our first triangle here. We've got ABC. You know that angle C is 68 degrees. You know that angle A is 18 degrees. And you know that B is 70. And now we want to find side A. We want to find this side. You can use side B, but we have to find angle B first before we can plug this into our formula. So in order to find angle B, we're just going to take 180 and subtract it from 18 plus 68. So angle B is going to be 94 degrees. So now let's figure out what our law of sines is. So with the information we've got sine of 94 degrees, and that's over the side 70. And then you have the sine of 18 degrees over side A. You are going to cross multiply, so you have A times sine of 94 is equal to 70 times the sine of 18. When you are solving, you're going to divide by the sine of 94. Plug that into your entire calculator. So A is 21.7. In 13, we're going to draw another triangle here. You've got A, B, and C, where A is 15, B is 20, and angle C is 72. So here we are going to use the law of cosines because when your angle is in between your two sides, we can use the law of cosines. So we are trying to find C. So we're going to use C squared is equal to, and you've got 15 squared plus 20 squared minus 2 times 15 times 20 times the cosine of angle C, which is 72 degrees. Now, when you are trying to figure out what this is, you can just take the square root. So you can just plug that entire thing in your calculator to find C, and you would get 20.97 for side C. So here we'll draw another triangle, and we've got A, that's 105, so I'm going to make it a little bit larger here. So here's A, 405 degrees, here's B, here's C. Our A is 80 and B is 100. We are trying to find angle B. So again, we're going to use the law of sine. So we've got sine of 105 degrees over 80 is equal to the sine of angle B over 100. Now when you cross multiply, you're going to get, let's see, 80 times the sine of B is equal to 100 times the sine of 105. When you divide both sides by 80, you have the sine of angle B is, and when you plug this into your calculator, what you're going to get is approximately about 1.207. Now, again, you're trying to find angle B. So whenever you're trying to find an angle, you got to do the inverse. So whenever you try to find the inverse, you just press second, and then you press either sine, cosine, or tangent. So you can get the little -1. So when I try to find angle B, I would have to do the inverse sine of 1.207. So when you plug this into your calculator, you're actually going to get an error. So that means that that's not a real angle. So you do not have a triangle here. Okay, here we go. Number 15, let's draw another triangle here. A, B, C. A is 20. B is 30 and C is 40. We are trying to find angle A. So angle A, although you don't see angle A in your law of cosines, okay, that still means that these are going to be the same angle and the side that's opposite to each other. So it doesn't matter what the letter is. The thing that's important is that the sides that sort of make up the angle, that's what's going to be in the inside of your law of cosines. So when we're going to write this, you are going to put 20 now on where the C is, even though it's not technically C. So you got 20 squared is equal to the sides that make up the angle. You got 30, you've got 40, you've got 2 minus 30 and 40, and then you've got cosine of angle A that you're trying to find. All right, so we're going to have to do some math here. This is 400 is equal to, this is what we're going to add together first. That gets you 2,500, and then minus, and then you are going to multiply these numbers. That's 2,400, and then cosine of angle A. You are going to subtract the 2,500 to the other side. Okay, we're not combining the 2,500 and the 2,400. So that gets you a negative 2,100 equals negative 2,400 cosine of angle A. Here is where you're going to divide. You're going to divide both sides by negative 2,400 because it's negative 2,400 times the cosine of A. So you're going to get about 0.875 is equal to the cosine of angle A. Again, when you're trying to find an angle, you got to do the inverse. So it's the inverse cosine of 0.875. And that means that angle is going to be approximately 28.96 degrees. Okay, and number 16, here we go. Another triangle, A, B, and C. Side A is 14, side B is 16, and angle A is 57. You are trying to find both possible angles for B. All right, so we're going to use our law of sines. So you have the sine of 57 over 14 is equal to the sine of angle B, which we don't know, over 16. You are going to cross multiply, so 14 times the sine of B equals 16 times the sine of 57. Divide both sides by 14. So the sine of angle B is going to be 16 sine 57 over 14. Whenever you are looking at finding an angle B, you are doing the inverse. You're going to do the inverse sine of everything that's here. So that angle is going to be about 73.43 degrees. So that's angle number 1. In order to find angle number 2, you are again going to take 180 and subtract it from 73.43. So the other possible angle B would be 106.57 degrees. I hope you found this video helpful. Don't forget to like and subscribe for a notification on other pre-calculus review. Thanks for watching and have a great day.